Hello everyone, in this video we're talking about the metal structure, so structures that are found in all metals. So in this lesson, we'll be learning how to link the physical properties with the structure and bonding in metals, learn the structure, the bonding and the particles that's found within metals, explain why metals have a very high melting point, explain why metals are able to conduct electricity. So we know that all metals have a very high melting and boiling point, and we also know that every single metal can conduct electricity in any state. And why does it have a high melting and boiling point? It's because there are strong attractive forces that is found within metal. And why can it conduct electricity? Because there are charged particles available. So let's think, what are the charged particles that are present? So the particles that are present are actually metal ions that are within a sea of electrons. So what are the bonding present? We know that metal cations are charged particles, and we know that electrons are also charged particles, negative and positive. And therefore, that when you have a positive and negative particle, there will be a electrostatic attraction. So the bonding present within metals is actually the strong electrostatic attraction between the metal cations, right, with the sea, all of the delocalized electrons. We have learned about delocalized electrons. It means that the electron have escaped the atom and can go anywhere it wants. Right? So how do we describe the structure of metals? So we describe structure of metals as it is a giant lattice of metal cations in a sea of delocalized electrons. What does that mean? Is that the metal cations are fixed in the position. Fixed position. So it's like a network of the metal cations. And the sea of delocalized electrons is where the electrons can fly around anywhere in between all the metal cations. So if you zoom in, it looks something like this, right? So you got metal cations, and the electrons that delocalize, right, can fly anywhere it wants. So where does these electrons come from? So like for example, in sodium, you know sodium is in group 1. So when sodium form a full valence shell and form an ion, it leaves 1 electron. So all the cations in sodium are sodium singly charged cation, and there's 1 electron per atom that flies around. For magnesium, because magnesium is in group 2, it will lose 2 electrons to form a full valence shell. So all the lattice of cations will be Mg2+, and there will be twice the number of electrons that actually floats around. And aluminium is in group 3, so it loses 3 electrons, right? And then therefore the sea of delocalized electrons in aluminium is much more, 3 times that of sodium. So actually there is a stronger attraction between the aluminium cations with the bigger sea of electrons as compared to the sodium cations with the smaller sea of electrons. So let us learn how to explain the high melting point as well as the electrical conductivity. So remember that when we're talking about high melting point, we always talk about bonding. So therefore metals are high melting point. And why they are high melting point is because a lot of energy is required to overcome these attractions. So remember, overcome attractions but break bonds. So this time we need to use the word overcome. So what are these forces? So since there are strong electrostatic forces of attraction between the metal cations and the sea of delocalized electrons, and as a lot of energy is required to overcome this attraction, therefore metals have a high melting point. Now let's learn how to explain why metals can conduct electricity in any state. So therefore metals can conduct electricity, and why? Because there's mobile delocalized electrons, something similar to graphite. Right? And as there are delocalized mobile electrons. So where does these delocalized mobile electrons come from? So since the sea of delocalized electrons can move throughout, right, the lattice of metal cations, and as there are delocalized mobile electrons, therefore metals can conduct electricity in any state. Right? It's a common mistake to think, right, that the cations in the metals move. The cations, the metals don't move. Right? They stay still. But it's the electrons that move from one end to the other such that you can conduct the electricity. So please take note of that, right? The metal cations don't move. It's actually the delocalized electrons that are mobile, right? So that's the metal structure, and I hope you can understand that. Please commit this to memory as well, right? All the best. Bye-bye.